Good afternoon, Dr. Neeraj.
Ashish sir, Dr. Ashish
Uh,
Kumar.
Ashish,
Yeah, yeah.
yeah, good afternoon. Welcome to the in for the demo session at Amity University in Tashkent. So, before starting your session, please give brief introduction of yourself, and after the introduction, then you can start your presentation.
Okay, sir. So myself, Dr. Ashish Kumar. I have done my PhD from Delhi Technological University in the year 2020, and presently I'm working with Bennett University, Greater Noida, India. And I have been published many research paper during my PhD, and I have 8 SCI papers, and one of my research paper is under IEEE transaction of cybernetics, which is having an impact factor of above 20. And I have in total 14 years of teaching experience at various levels and positions in various institute. And previously joining Bennett University, I have been working with Bharatiya Vidyapeeth College of Engineering affiliated to GGSIP University, New Delhi. I have done my MTech from GGSIP University in the year 2009 with distinction, and I had done my BTech from MD University in the year 2007 with honors. And I have been residing in India, Gurugram, Haryana, presently. And I have been granted one patent, which is based on IoT for aquaphonic systems last month only. And I have been published many research papers in many international and national conferences. I have published many in Scopus Index book chapters, and I have been editing and authored many books on object tracking in computer vision.
Yeah, okay, then share your presentation and please start the demo.
Okay. Sir, screen is visible.
Yes, yes, it's visible.
Okay, thank you for confirming. The topic of my presentation is multi-queue object tracking in video sequences. First of all, we need to understand what is object tracking is. But before that, I will let you know about the outline of my today's presentation. So in this presentation, I'm going to cover three main topics. One is the introduction. Second one is my current research area. And then I will be showing few of my research paper publications, which are published in various SCI book chapters and the edited books. In the introduction, I'm going to cover about the applications of object tracking, various challenges that make this object tracking interesting, and will give a brief introduction of one of the research paper that I have published in multimedia tools and application during my PhD. And the title for that is Real-Time Object Tracking via Multi-Queue Based Adaptive Particle Filter Framework. So let us start with the introduction. And first of all, we need to understand what is object tracking is. So object tracking is basically focused on a target object which is being identified in the first frame of a video sequence. And object tracking will keep the location localized that particular frame target in the subsequent frames of that video tracking of a video sequence while catering various video challenges. And for keep tracking the target in various video frames, we need to extract multiple features or single features from the target. So but the single features are not reliable enough to keep the tracking challenges, to handle the tracking challenges. So multiple features are being combined together to obtain better results in a typical scenario. So multi-queue based trackers focus on combining the complementary multi-physical queue, which can compensate for each other during various tracking challenges. Broadly, the object tracking frameworks are classified into stochastic framework and the deterministic framework. So stochastic are basically probabilistic framework, whereas the deterministic framework will work on fragmenting the target and keep the track of the target based on the fragments that are obtained
Excuse
from the.
me, Dr. Ashish. Slides are not changing. I think still we are just having first slide.
Okay, I
Kindly
think I
reshare.
need to then, yeah, I need to reshare it. I think then I need to share my entire window. Are they getting changed now?
Yes. It's visible now.
So shall I repeat or will continue from this slide onwards?
No, please continue.
Okay. So now we'll come to the application of object tracking. Object tracking is basically used for recognition of motion-based systems that involves the tracking of the vehicles which are driverless cars and the systems that is going to be applied in the future. It can be used for surveillance, for detecting any troops in typical areas like in a scenario where there is a lot of snow over the mountains or during hilly areas where there are a lot of trees were there. So the object tracking is very useful in traffic monitoring and vehicle navigation. When the object is moving over the road, it is important to identify the obstacle which came in between and or to prevent the collision with those objects. That object tracking is helpful in these scenarios. So object tracking is basically consists of three main steps. The first one is object representation, where the object can be represented either using a centroid or multiple points over the target. And then the main focus is to extract the features out of those targets so that it can be localized in the subsequent frames. Then there is an algorithm which is being applied for the object tracking, whether it is based on single or multi-model estimation, and then update model which keeps on updating the model as per the change in the target so that it can be localized in the coming frames of the video sequences. These are the challenges which make object tracking interesting and challenging. The first one is the illumination variation that deals with the change in the lightning in the system. When there is a change in the lightning situation in the system, it is being tough to keep the track of the target when there is a change in the lightning scenario. Then we have an occlusion where the target may be occupied by the other objects in the scene. There may be the case where the target is occluded by single or partially or fully occupied by the other targets in the scene. In that case, it is quite tough to keep track of the target when we keep on changing the frames. When the another one is the background clutter, when the background is of similar color to that of the target, in that case it is tough to identify the target and extract the target from the similar background. Then another one is the object rotation. When the target is getting rotated, its motion is getting changed, its situation, its angle is getting changed. Then the scale variation, when the small target is either moving towards the camera or it is moving away from the camera, then the scaling of the target is getting changed. Then the motion blur, when the target is moving slowly, or it may be due to the camera positions that makes the motion blur in the captured video. Then we have a fast motion when the target is moving very fast. In that case, the frames are getting changed very rapidly. In that case, the target tracking is quite tough. And the third and the last and not the least one challenge, that is the pose variation. When the target is completely swap its position, in that case it's quite tough to keep the track of the target when keeping it while tracking it in a video sequences. So now we are coming to this current research topic, which is about the real-time object tracking via multi-cube-based adaptive particle frameworks. So in this particular case, we have used particle filter as the base to keep the track of the target. The reason for choosing the particle filter is that it provides the two states, which is totally connected with the object tracking. The one is the prior state, and another one is the posterior state. So based on the by estimating the prior state, we can estimate the posterior state, which is the main requirement of object tracking, where we will try to locate the target in the next frame based on its present or the previous position. So that particle filter framework is used for estimating the target state in the subsequent frames of video sequences. But the particle filter is suffered from two drawbacks, two limitations of particle filter are there. One is the particle degeneracy, and that particle degeneracy will lead to another problem, which is sample impoverishment. So particle in degeneracy is like when the target is moving from one frame to another, then the target is occupied by many other challenges that we discussed just now. So when the target is affected from those challenges, the particle weight will become negligible, and then they were not able to contribute towards the state estimation of the target. So in that case, those particle processing of those particle will lead to the wastage of computational power. So this is the particle degeneracy. And in order to solve this problem, some algorithm are applied, but when those algorithms are applied, sample impoverishment will come. So that sample impoverishment where the particles weight are becoming high and they are being occupied in other likelihood area, which is of no interest. So these two problems need to be catered while we are dealing with the particle filter in the object tracking framework. So in this particular case, we have proposed this architecture. This particular architecture is there where it has certain block diagrams, main block diagrams are there. The one is a prediction state and the second one is the update state. Then we have a queue reliability, we have outlier detection, and the resampling technique to address the sample impoverishment and degeneracy problem in the particle filter. And then we have a reference histogram dictionary to keep the target updated with the changing scenarios in the subsequent frames of video sequences. So the first one is the update state. In this particular case, we have taken three queues. Each particle, we have taken 49 particles, and for each particles we have extracted three cues. One is color, second one is LBP, and the third one is the PHOG. So these three complementary cues are extracted to make sure that this target will not fail during the tedious environmental situation. But when we are extracting this three cue, it is important to make this queue club together, fuse these cues together to obtain a final score. So these three queues are being fused using a proposed fusion model in which we have extracted the weight likelihood out of these three particular features, and then we have fused these features based on non-linear fusion model. And then finally, when we obtained the fuse likelihood, we have used a queue reliability in order to determine the importance of a feature during the tedious environmental situation. Let us take an example where illumination variation is occurring in the scene. In that particular scene, the color likelihood is of less importance in comparison to a texture and gradient queue. So in that case, the queue reliability
आशीष सर हेलो सुधांशु सर एक बार आप बात करिए तो उनसे, आशीष सर से।
Okay.
रवीन सर, कुछ टेक्निकल इशू आ गया क्या, तो रिजॉइन कर रहे हैं?
हाँ, it's okay. We are waiting.
Sorry, sir, I got disconnected. I'm just connecting my sharing screen again.
Yes, please.
Hopefully the screen is visible. So we were discussing this object tracking model in which we have been taken three cues: color, texture, and gradient. And we have used these three cues using a nonlinear fusion model in which we have ranked this likelihood. And we have also used a Q reliability to identify the importance of a Q during various tracking challenges. And then we have applied outlier detection in a scenario in order to determine those particles which are not being which are being affected a lot using the challenges. So there is no point, and they are contributing less towards the state estimation. So there is no point in spending time over the processing of those particles. So outlier detection is helpful in detecting those outliers. And the resampling technique, proposed resampling technique, is useful for modeling for handling the sample degeneracy problem of the particle filter. And the reference histogram dictionary is used to keep the target adaptive with the change in scenarios, and to keep the challenges, to keep the keep the output of the tracker efficient. So these are some ideas for proposal for funded research on which I am working in. And the one is the multiple cooperative drone-based surveillance system for enhanced security. I have been submitted this idea. My co-supervisor is from his name is Dr. Gurjeet Singh Walia, and he's a professor. He is a scientist at DRDO. So with his help, I have been submitted this funded research project in DRDO so that I can extend my PhD work. In this case, we'll be using multiple cooperative drones to enhance the security system for the troops and the valleys, where we will try to identify the troops, and in the valleys and the scenarios where the troops are wearing the similar kind of clothes as per that of the vegetation, background vegetation, and during the snow captured area where it's quite tough to identify those troops which are coming from other countries to try to enter into India. So this surveillance system is helpful in identifying for enhancing the security, and we have been working and submitted this project to the DRDO. And another funded research project on which we are working in. So this tracking target, this is again based on my research work which I done during my PhD only, and this research work is helpful in keeping the track of the target during a tedious environmental situation. So these are the references which I have included in this, and any question answers. And once again, sorry for I got disconnected due to some Wi-Fi shift. So sorry for the inconvenience caused.
Yes, Dr. Assis. Yeah, it was a good presentation, but it was very short.
Sir, I was aware that it is going to be 10 to 15 minutes lot of time, so I prepared accordingly.
Yeah, it's okay, fine. So you have published so many research paper, and in one of the paper, which one is your latest paper in 2023?
Sir, there are two papers. The one is that explainability paper, which just got accepted, which is being online as well in multimedia tools and application. And today, one of my research paper, artificial for accessing the bias in artificial intelligence, got accepted today only.
Okay. And here in your resume, I can see that one paper that explaining sentiment analysis result on social media text through visualization.
Yes, sir.
What is there in that paper?
Sir, in that paper, we have used explainable AI to detect the sentiment analysis in social media posts. And in that, we will try to explain whatever the sentiment analysis we do, like whether it's a good or a bad thing. So based on that, we will try to explain using artificial intelligence scenarios like LIME and other parameters of that explainability to explain what the AI can do for the sentiment analysis in case of social media.
Okay, and
we have used LIME, Vader, and these techniques of explainable AI, which are helpful in explaining the outcome of explainable artificial intelligence in case of explainability.
Right. So we here in Amity University in Tashkent, we have two courses, and in this year we are adding one more, BSc IT in cybersecurity and data science. Right. So we have BSc IT, BTech Computer Science, and MSc IT. So here we have courses like software engineering, artificial intelligence, and machine learning and neural network. So are these compatible for you? That could you take this software engineering, machine learning, deep learning, and all? Is it okay for you?
Yes, sir. Software engineering, I have taken 2 years back in my institute when I was taking the classes for information technology department students. And machine learning and deep learning, I will be used to take the classes of the students during their summer internship in my previous organization, where a course of 2 months is being given to the students so that they can pursue during their summer vacations, like a summer school that we hold. So I'm comfortable with these subjects. So I have already taught, so there is not a problem to take them up.
Okay, right. Great, Dr. Ashish. That's all from my side. Other panel member, if they have any question, please ask.
Yeah, good afternoon, Dr. Ashish. This is Dr. Gaurav.
Good afternoon, sir.
Yeah, just I want to curious about, like, in many of your papers, there's like particle tracking. It is just like a optimization technique or something else? Like particles on optimization, PS. So it's like that or something else? It's
No,
tracking.
sir. No. It's not about particle optimization. It's about tracking. Like we have taken a target and we have initialized target particles over those target to identify the various features from those target. So we have created a region of interest over the target as a rectangle, and in that particular rectangle, we have initialized the particles. Like in this particular case, the paper that I just discussed, we have initialized 49 particles, and for each particle, we extracted 3 features: color, texture, and gradient. And then we have fused those features using our nonlinear ranking framework, Fusion framework. So we have not used optimization for optimizing the particles, but we have used the optimization to address the limitation of particle filter, which is sample degeneracy, where the most of the particles will accumulate at particular likelihood area. So we need to just spread them so that we can locate the target in a better way.
Yes.
So
and
for that we have used optimization.
Yeah, great. And in one paper, I just read about crowfly something. Crowfly. I think this is one more technique for particle gradient.
What, sir?
Crowfly. There is something crowfly in your paper.
So that is not a crowfly. That is one of the crow optimization technique where that is an optimization technique which identify the behavior of a crow for optimizing the particles. So we have used that particular technique, that particular optimization technique, which is based on crow for our tracking particles. Again, the same optimization is used. Yes, sir. That is used for addressing the problem of particle filter.
Yeah. So have you applied for other things, like one is spider monkey and other these kind of techniques are there in the literature? Have you used other things?
So spider monkey is already being applied by other authors. So we don't get a chance to apply that. So we use the recent one that is available for us for optimizing the particles. It is being already applied by the other researchers.
Yes, that's why I'm asking. Thank you, Dr. Ashish. Thank you from my side.
Thank you, sir.
Hi, Dr. Ashish. This is Rajan. I just wanted to know that the projects which you have done, have you deployed this project on the cloud or somewhere? And if yes, what were the challenges you have faced? And secondly, I wanted to ask, how do you identify the accuracy and performance of your object tracking algorithm?
The answer to your first question is that we have not deployed this thing over the cloud because there is that the deployment over the cloud is not the part of our research project. So we just implemented these things and extracted the result, accuracy, and other things primarily on our machines only. So whatever the implementation is done, it is done in Python, and we have collected the results and we generated the result over the MATLAB so that the visualization of the results and the graph would look better in comparison to the Python that we have generated. So what the second answer to your second question, that how we can evaluate the accuracy and performance of our object tracking algorithms. So there are multiple performance parameters available. So the first one that we have used is CLE, center location error, where we have calculated the CLE in a frame for the average for the bounding box predicted by our algorithm and the ground truth bounding box which is available. So we summarize, we average all those frame errors and we presented it in a form of table so that the average center location error can be presented in a particular video sequences, and it can be compared with the other tracker as well. And the second performance parameter that we have used is F measure. That F measure is used to predict the overlap between the bounding box which is there and the predicted bounding box. So F measure is another performance parameter that we have used. And then we have used AUC curve as well, every area under the curve. And we have used decision precision as well. We have used overlap precision as well. And we have used two types of plots for comparing the performance of our algorithm. One is the success plot and the another one is a precision plot. Where in the precision plot, we have plotted the average of our precision overlap thresholds over the multiple threshold overlap threshold. And in the success plot, we have plotted the success rate over the various center location error threshold that we calculated using our algorithm. The performance of the algorithm which is under the tedious environmental challenges. So these are some 5 to 6 performance parameters which are used to compare the accuracy and the effectiveness of the algorithm.
And
against the
can
other
you
state of
also
the art.
use some pre-trained network for your work?
Sorry, sir?
Pre-trained network can you use for the work? Is it
No,
possible?
sir, no, we have not used any pre-trained network for.
Is it possible to use, for example, in convolutional neural network, there are various pre-trained network available. Is it possible to use in object tracking
Yes,
system?
sir, yes. It is 100% possible to use the pre-trained models over this algorithm. But the point is that sometimes when we are using the pre-trained model for processing these video frames, it takes a lot of time. So the performance of the algorithm is another major challenge that's to be addressed while by using the pre-trained model and processing these sort of video sequences in a manner. So earlier when I started working over this, there were the dataset which are limited in size, but nowadays, just last year, a big dataset has been published by the reviewer, by the researchers, and that dataset is helpful in training those pre-trained networks and improving the accuracy and the performance and the computational complexity. So at that time when I started working, it was not there. So we can extend that work over those pre-trained models as well, no problem.
Okay, thank you. Thank you.
Yeah, any more questions from other panel members? Yeah, I think it's okay. Thank you, Dr. Ashish. It was a great conversation. Thank you very much for the session, right?
Okay, sir. So shall I leave now?
Yes. IT team, please. Yes, you can leave, Dr. Ashish. IT team, please close the session.